In today's lecture, we will talk about the concept of sequences, or you can say series. If we are talking about the concept of sequences, we should keep in mind that sequence is generalizing the arrangement or some particular order. If we see mathematically, we can say we can talk about some numbers. For example, 1, 2, 3, 4, and so on. See, there is a particular sequence from one integer to the second one. That is the addition of plus 1. From 2 to 3, again addition of plus 1. From 3 to 4, again addition of plus 1. Sequences can be arranged with certain rules, and these rules are following the multiplication, division, and other basic mathematical stuff. Let's see another example. If we have 1 over 2, 1 over 4, 1 over 8, we can notice that from first to the second value there is a division of 2. From this term to this term is again division of 2. From this term to this term, again division of 2. So arrangement of numbers or arrangement of systems is telling about the concept of sequence. In this scenario, we can further enhance it to the concept which will derive from the derivative, as derivative is telling us information at an instant, and the integral is telling us about summation of all the information. Here the concept of sequence with the help of derivative and integral proceed us to the next level, and this next level of course is very much important and interesting for building or you can say in construction or hierarchy of the systems, computing models. So this, it is very much important that sequences are fundamental to the study of infinite series with various number of applications. In mathematics, the concept of Newton methods, as I already discussed in one of our previous lectures, that with the help of guessing, initial guess and then the further iterations, we are getting a series of guesses, and this series of guesses are the, you can say, sequences of guesses are having some particular pattern. So to explore generally sequences of number, we can understand that it follows the conditions which they can converge or diverge the system. If we are talking about the convergence, we can see the concept of stability. For example, this is a Burj Khalifa in Dubai. It's multi number of stories on one another. Of course, the wonder of engineering with the help of convergence criteria, that building is established, it is not falling down, it is not demolishing, it is of course without a natural disaster, it is stable, and this stability is achieved with the help of convergence. If we are noticing some particular area, of course it is determined with the help of derivative. If we are covering from top to bottom, of course, it is, you can say, cumulative sum of all the stories. This is telling us about the integral, and arrangement of one story on another, or arrangement of this setup is achieved with the help of convergence criteria, that building is, this whole wonderful Burj Khalifa is in a stable condition. One more concept of convergence can also be noticed with the help of light. That direction of light, if it is focused on one point, it is telling us the concept of convergence. If it is not focusing, or you can say it's not stabling, of course it is the diverging. Furthermore, we can also think divergent, such that we are, notice that, create too many choices or lot of information, not a conclusion point, is telling us about the divergent. And once we are making our choices and finalize it, then it's the concept of convergent. Lot of choices or creation of choices is telling us out about the divergent, and focus or finalizing as a convergent thinking. Let me create some scenario in which we can see the sequence which we are usually observe in textbook notion. For this, I want to create a scenario, and according to this scenario, suppose there is a metropolitan city. Okay, condition 1 is metropolitan city, such that power, or you can say transmission line, is needed to pass through that area. Transmission, electric power lines is needed to pass through that area. The third one, situation of metropolitan city, situation, or you can say complexity of that city. Let me make a diagram for this. For example, the situation, or you can say complexity of city, is such that there is a canal, or you can say some stream of water is passing through the center of this metropolitan city. On one side of this metropolitan city is skylines, too many buildings at the one edge, or you can say at the bank of this stream, this canal. So very well populated, or you can say saturated. On the other side of this river or canal, you can say there is a bridge. So the conditions are very much strict. Power line, these transmissions or power lines is required to pass through this area, but it is strictly prohibited that this power line should not touch any of this building, or the pole should not be placed in between the residential area, or you can say that the multi-story area. On the other side, there is a bridge, and again huge number of stories or skylines, very well populated. So it is not permissible to pass through the transmission line from that red area. It is also okay, red area is strictly prohibited for passing the transmission lines. Transmission lines, you can say, so this red area is strictly prohibited for passing through the lines, and bridge is also not allow any placement of the poles on the bridge, but space beneath the bridge can be utilized for any purpose, but pole should not touch the bridge in any way. Just at the edge of this bridge there is a stream, you can say water canal. So this electricity pole should not touch the water. Now this red line is a skyline, or you can say that buildings. Pole should not touch this area, pole should not touch the bridge, or pole should not touch this water stream or canal. Situation is this: it is strictly prohibited to use the underground area of this stream or this river for passing through the transmission line is of, you can say that, of high voltage, very high voltage. Transmission lines are, so it should be in an open arena. Only one situation is possible to construct a pole for passing the transmission lines. It is the green area that is just beneath the bridge. Such a way, the base of this pole should just lay down on the green area, and then it is pole is just placing beneath the bridge in an inclined way, such that its top should be somewhere in the center, and its base should be here. For this, the top block should be at further position from the base block, such that it should look, because the base block is just exactly beneath the bridge, but top block should away from the bridge, so that transmission line can be passed with the support of this. And of course there is a water stream like this. Situation is just like this. Let's see how we can construct it. Let me invite some of volunteer students who can perform this with the help of certain blocks. Let me provide you a number of blocks. What is your suggestion, please? How?
Sir, if we pass them in the form of a curve under the bridge, bridge के नीचे से अगर curve की form में
over the bridge.
No, not. No, it's see under the bridge in form of curve. You wanted to say that this not allowed.
सर ऊपर मतलब अगर हम इस तरह लेकर जाएं तो
Then where will you need to provide support to these cables?
poles
From where you will get this support? Pole. Where will you place the poles? Question is this. Here scenario is this. This is the water canal. You should not allow to touch the water, or you do not allow to use the bed of the water canal. On one side there are too many buildings. Just at the edge of the you can say canal or at the bank of this river. So you do not allow to touch any building, okay? And on other side, in the green line, it's the bridge. You do not allow to use bridge, or you do not allow to place any pole on the bridge or under the bridge. Exactly, because on the bridge is very much sophisticated. Under the bridge, power lines are very much dangerous. You do not allow to pass through the power lines under the bridge. Okay, and this whitish area, so populated or metropolitan area, you do not allow to disturb this area either, or placing of poles. Yes, please. One thing is there. This is this area, but we do not allow to touch the water.
सर दोनों बैंक्स पे पोल
You mean to say this is one, this is the B? Are you getting?
Yes, sir.
No. On this bank, this side and this side,
yes sir
Yes, sir.
I told you do not allow to touch either of the bank.
So bridge बना लें.
सर एक टाइम तो आ सकती है पोल
No, they said that not. Do not touch. This metropolitan is just at the edge of this bank. You should not touch. You should not allow to place any get support from this side. Other side, this yes. What you are right in this scenario that under the bridge it is acceptable. You can get a support, but power lines cannot be passed through under the bridge. But you can get a support just beneath the bridge, because there is some space beneath the bridge. With the help of that support, you can construct
ऊपर से
a
नहीं
pole.
लेकर जा सकते सर
No. Yes, please. Anyone like to suggest? Come on, okay? Yes, you can use the space just beneath the bridge, and you can construct a pole with the help of some intellectual approach.
Sir, beneath the bridge there is also water or
No, just beneath the bridge there is a land. Of course, I have said that for example, this is a bridge, okay? This is a bridge. Here, see, just exactly beneath the bridge there is a land. Okay, because bridge is standing on a land.
टेढ़ा पोल लगा ले
Okay, yes, good. Would you want to construct a pole in form of, okay, in terms of inclined way, but how?
सर बेस स्ट्रांग कर ले खड़ा हो गया तारे में
Okay, with the help of strong base, but how? For example, here, the question is this: you want to construct this is suppose this one, blue one, green one is a bridge. You want to place some kind of okay, just this one is the base, okay, this one is the base. Are you getting my point? We are inclining it like this. So, at the center, of course, two places you can place it in an inclined way. And then you pass through the transmission line on it. Yes, it is acceptable. But how? It is possible.
So we can support it using the
edge of bridge.
No, do not touch any part of the bridge. You can just use the land beneath the bridge. Okay, if I am observing, your point is good, but it is not permitted. Okay, this way, yes, inclined pole we can use, but in this situation, here I am drawing this one on a side face, for example, the side view. Are you getting my point?
Yes, sir.
Side view. There are too many, such that you are, remember that this topper block should away from the lower block. Then it will work. Are you getting my point? So suppose this one is a bridge. So topper one should not touch it. Okay, let me. Or it should. Okay. Yes, it's a bridge. The first block should. Okay, first the base of a pole can be just beneath the bridge, but its top should away from the bridge. Are you getting it? So if we are constructing, the top block should away from the base block. Okay, just of course it is kind of a pole, but here you should need to construct. Suppose with the help of blocks, how you can construct it. Should I provide you block? Will you try to construct it? Other one, will you try? Come outside. I have blocks for you, okay? Construct this. Yes, your top block should away from the base block. Yes. Yeah, I especially visited to the carpenter for getting it. Yes. You should here in a model you don't need to use any glue or any kind of stuff, okay, screw. Here you should place it just with the help of this pattern. I want to notice how you can do it. Someone have a scale? He constructed it this way. Sorry, can you please construct it so the other can see it? I'm so sorry. That's okay. I wanted the top block should away from the base block. This is the condition. I will notice it with the help of this scale, okay? Yes, here. Yes. Let's just. This is the top block. Can you see the top block again just on the base block? Not exactly away from the base block. Is it clear to all of you?
Yes, sir.
Can you see? Gentlemen, can you please come to this center, their center seats? The top block is at the, see here, this one is the top block. Technically, this top block, for example, this one is the top block and this one is the base block. This top block should like at this position. But it is at, okay, just try. Anyone else want to try? Yes?
So can we use more blocks?
Yeah, of course, there are too many blocks, okay? You want to try more? Yes, please. Yes, please. Think, then just sit down. Come. Yes, come. Just try, come, hurry up. It's not a big deal.
Can we use sport?
No, my daughter, sport is not permissible. Okay?
इसके ऊपर रखिए ना next
Come outside. Don't instruct them. After this, you are done. Just think. Okay, okay, my daughter. If you allow, he want to try. Okay, okay, he is guiding you. Just yeah, very well. Okay. Then if you will use this kind of sword, it will touch the bridge boundary.
सर थोड़ी तो ब्रश की जगह होनी चाहिए.
Just both sit down. Sit down. This is not,
sir.
or even not.
ये ब्रश के साथ तो.
Here, just even not. Just even not. It was just on the base. Okay, you sit down. It is not. Yes, please. Come, please, my son. Please, my dad. Okay, after this, okay, you can. Hurry up, please. Just wear the corner so that I can just try to bring it. Okay, it's your job. You can do it.
Make the best.
So you are the future of Pakistan, okay?
Yes,
Yes,
sir.
sir.
It's enough.
That's not good.
It will not work, my son. It will not work. Take off, okay? Otherwise it will fall all. Just see here, even the base block, okay, it's almost 70% on the base. Come, my daughter. Hurry up, come. Hurry up, just come outside. Just try and don't interrupt, okay? Hurry up, just blast. After your turn, see, get ready. Think what you can do. 100 rupee is cash award. Okay, 1,000.
Should I do it?
Just after this, after that, try. You both want to do? Here, this is not requirement. You are taking the net how to do it.
No, sir.
Then what are you doing? Playing games?
Sir, lecture.
Just close it. My son. Just please. That's okay, please. Don't argue with one another. Get ready. She can't do that. Yeah, mathematics is really
Mathematics is too much difficult.
My daughter, I'm so sorry. Please come see.
I'm sorry.
Yeah, that's okay. Please come and see. Please. And after this, you are done.
Sir, I was trying this thing.
Yeah, yeah. Sit down, okay. Sit down. It will not work. It will not work. You can try, but it will not work. Come, try. Complete your try, but it will not work.
Sir, I was also trying like this.
Then you should not come.
Okay.
No. Okay, sit down. Thank you so much for your kind support. Of course, interest is required to do the wonders of the world. Okay, so it is not wonders of the world, but at least we can try. This requires mathematics. Let's consider n number of blocks. Let me make such that we have the this is the top most block, and the center of mass for this block, if we consider its measurement as 2 unit, at the center of mass of this block is equivalent to 1. The center of mass at the edge of this block, this is the edge, so center of mass of this block is, suppose it's the initial center of mass, we can say there is no center of mass at the edge of this block. However, in its center point, center of mass of this block is considered as C sub 1, center of mass as this first block equivalent to 1. Let's consider another block. Now this is the second block, and this center of mass of first and this block is equivalent to of course I am considering this, let's say in the center, so we need to determine what should be the value of this one, center of mass that is holding these two blocks. Similarly, center of mass for this block, if we are having n number of blocks and all n number of blocks are positioning on the ground, these are the n number of blocks, and all these number of blocks are positioned like this way. This is the bottom one at lowest position, that is on ground, so all these are positioned on this block. So center of this block is having center of mass of itself, that is, if we are talking about this block, it is itself along with the n number of block. So here we want to know center of mass of n plus 1, that this 1 is representing itself, center of mass of this block itself, and n is representing these n number of blocks, so this is one. So we need to determine the sequence for these number of blocks which we can place such that it should converge or it should stable in order to support the power line, or you can say transmission line, with good sustainability. So we need to determine this sequence. Let's construct a formula for this sequence. See, if we want to know center of mass for this n plus 1 block, if we are talking the lowest one, of course it is, let's change the color, the first one, that is block on a ground. I'm talking about this one, this is on a ground, just beneath the bridge. So itself is 1, and this first block is holding a center of mass for center of n mass for n number of blocks plus itself. Now other thing which is information, or we are summing up all the information for n plus 1 number of blocks. So for n number of blocks we can notice that center of mass for n number of block is given with C sub n, and for normalization we need to divide this whole with total number of blocks, that this one is the 1 and this one is the n, so total number of blocks are n plus 1, so divide it with n plus 1. Let me rewrite this equation on the next slide. So here it can be written as it can be simplified further. Here we have some common terms, this one, so we can write Cn 1 plus n plus 1 n plus 1. By further simplification we will get C n plus 1. Here by splitting the denominator in two terms we will have Cn n plus 1 n plus 1 plus 1 over n plus 1. It will be cancelled out. We will have Cn plus 1 over n plus 1. This is the mathematical information for its convergence criteria for stability of these number of blocks in order to construct a stable tower for passing out the transmission lines. So we know the center of mass for at the edge of the topmost block, or you can say that C sub 0 equal to 0. Here we know this one. We also familiar for the first topmost block, the center of mass at its center, so equivalent to 1, C sub 1, the first block, and C1 equal to 1. Now by using this equation we can substitute the value such that once n equivalent to 0, the equation 1 become for n equal to 0, equation 1 becomes C1 C0 plus 1. It is for cross checking. By substituting the value of C sub 0, we will conclude 0 plus 1 equal to 1, and we are verifying it that C sub 1 center of mass for topmost block is equivalent to 1. Now in order to determine the center of mass for the second block, third block, so for n number of block we will proceed further. such that for n equal to 1 in equation 1, it will becomes here by substituting n equal to 1, it will 1 plus 1 become 2, so we will have C2. Here by substituting n equal to 1, we will get C sub 1. Here by substituting n equal to 1 in denominator, we will get 1 over 2. By placing the value of C1 from above equation, we will get 1 plus 1 over 2. Similarly, for third block, for n equal to 2, by substituting this in equation 1, by placing n equal to 2, it will provide us C sub 3. Here we will have, by placing n equal to 2, we will get C sub 2 plus, here by substituting n equal to 2, we will get 1 over 3, in that 3 in denominator. Now by placing the value of C2 from above equation, that is 1 plus 1 over 2, we will get 1 plus 1 over 2 plus 1 over 3. In this fashion, we will determine the sequence for C sub n plus 1, such that 1 plus 1 over 2 plus 1 over 3 plus 1 over 4. But it should be less than 2. Why? 2 is the maximum scale or maximum unit for the size of block. So it should be less than this one. Did you notice that while we are placing or we are constructing a bridge, with the help of blocks, we are getting this information, and this information can construct or can help out to construct a bridge beneath this information of sequence can help out to construct a pole in a convergence sense in order to pass through the transmission line from this central area without disturbing the water, without disturbing the building. Just by utilizing the place underneath the bridge, we can arrange a system, or you can say successful system. So this is the beauty of sequence. We can use it by considering the derivative as well as integral as its basic parameters, and finally we can converge a system. And convergence of system is telling us about the stability. If system is not convergence, then it means this pole, or you can say this construction, is not stable. It will be demolished. It is not sustainable for passing the transmission line. So this formulae help out to attain a convergence sequence, such kind of sequence. And let me show you with the help of blocks. Okay. Let me construct a system for you with the help of these blocks, such that let me construct a system. Wow, this is constructed in such a way that topmost block, it has farthest position from the down one, as you can see at the lowest. Can be further. This is showing that with the help of proper sequence, that from the first block to the second one there is half, next 1/3, next 1/4, 1/5, 1/6, 1/7, similarly 1/8. So we are attaining a beautiful convergence such that the topmost block is at farthest position from the lowest or the bottom one. Let me show you here with the help of this. You can check out the gap. So this is telling us that the sequence, beautiful convergence sequence, that is the stability, can be achieved with the help of mathematics. And once, if this is not following the correct mathematics, correct arrangement of order, or you can say correct orders, then of course it will be demolished. It is not stable or not convergence. So this is the divergence. Thank you.